Okay, it's 11 o'clock, which means it's time to get started with our virtual workshop. My name is Sonia Pryor-Jones, and I am a member of the team at the Fab Foundation, where I serve as the Chief Implementation Officer, supporting our education team. And today we're really excited to present another virtual workshop to you. For those of you who are not familiar, the Fab Foundation, our mission is to democratize digital fabrication. So we want to make these tools accessible to people everywhere. And we're particularly interested in doing that with teachers and students in schools, even during quarantine. And so the entire Fab Foundation education team has been working really hard to put together a virtual series where we can, even without machines, at least get to the heart of digital fabrication and some of its core principles and share those with you. Today, we're super excited to have one of our team members, Dan, lead us through the way, along with some wonderful members of our network. And so I would just encourage you all to keep track of our emails as well as our website. So whenever we're having things like this, you can take advantage of it. So thank you for being here, and I'm going to turn things over to Dan.
All right, thank you, Sonia. Good morning, everyone. Thank you for joining us on this Friday. I'm going to get started here. This is our agenda, pretty simple agenda. I'm going to first give some updates on the SCOPES community. Many of you know that I also help build and manage the SCOPES project. And so I always, whenever I get the chance to lead a SCOPES meeting, I like to share some of the insights on like kind of what our community is up to, how we're doing. I'm then going to go straight into the main content area, which is creating design workflows across digital tools. A lot of this is tied to 3D modeling and how we can use a 3D model to generate cut files for digital manufacturing, digital fabrication. And a lot of these tools are just not, people don't know about them yet. So I'm excited to share some of these tools that really help bridge that gap. But importantly, during this pandemic, we need to focus and develop skills on the digital design aspects, things that we do access to. Many of us don't have access to our fab labs. So this workshop is in part trying to build, provide resources. While you don't have access to machines, you do have access to other tools that we can develop skills in. We're gonna leave about 10 minutes towards the end, at the end, for Q&A. If you do have any questions, please type them in the chat window, and we will get to those, or just wait until the Q&A, and we'll kind of open up the meeting. We'll right now, I think you can only see us, the panelists, and the Fab Foundation staff. For Q&A, we'll allow everyone to share their video and audio for that. So just a heads up. And then we'll end with a call to action. We've put together a call for unplugged lessons. That's what this one was in response to. My response to the call was the unplugged lesson. So we'll leave with that. So let me go ahead and get started. I first want to give a big thanks to our two panelists from the community, Danielle Martin and Katy Perry. They both have been major contributors to the SCOPES project over the years. I'm showing two examples here of lessons that they've uploaded, created and uploaded on our site for everyone to use. So I encourage you to check those out. But I did want to give just an opportunity to Danielle and Katy to say a couple words. I know you both are busy, active teachers, so it's always good to hear what you're up to and where you're from and things of that sort. So Danielle, do you want to say a few words?
Sure. I'm Danielle Martin. I am a high school career technical ed, engineering, and makerspace elective teacher in East Palo Alto, Bay Area, California. And when we are together, we have a beautiful dream lab. I might turn it on. I have a background of it that looks like I'm sitting in it. And yeah, so formerly I worked with the Computer Clubhouse Network and with the beginnings of the SCOPES project and Fab Foundation. So I'm excited to be here today.
Thank you.
And hi, I'm Katy Perry, and I am the STEAM coach and makerspace coordinator for Schenectady School District in Central New York. And I've been involved for the handful of years operating a mobile lab through all of our K through 12 classrooms as much as possible. And I'm excited to be here helping out today as well.
Thank you both so much. And just a heads up, I do know, Danielle, that you might have to jump off, so we might lose you towards the end. So I just want to, Danielle's teaching her own class right during this. So we want to thank her very much for giving us her time. You know, dividing up all of her time like this can be hard. So thank you very much for doing that. I want to say a few words about the SCOPES community. I pulled this picture from our SCOPES-DF community page, and I always like to look through it because I start to see so many faces that I can connect with, that either meeting at a conference or talking on you know, on another Zoom call. It's really, I get a lot of pleasure out of just seeing all the faces. So I really want to acknowledge that all the work that we do is really built from the work that you all do as part of the community. And it goes along, and you know, your work goes a long ways. So I always want to call that out. This is the one slide that I prepared to talk a little bit about kind of our community health. We started this project in 2017. We've been tracking it with more fidelity since 2018. And what you're looking at is a year-over-year activity on our web platform. And so you can see 2018 is in the green in the very bottom of the screen. 2019 is activity that you see in red. And then 2020, this year, is where we're at now. So I'm excited to share this because it's one thing, it shows that we have a good pulse. As a community, we have a steady, like, solid pulse. That's kind of how I see 2018 and 2019. And in 2020, I see this is like nearly a 300% growth in our activity. So it always encourages me to see this growth and to see how we're kind of, you know, providing that many more resources for teachers all around the world. So I just wanted to share that with you all. But that being said, I want to jump into the content of the workshop now. And just so everyone knows, what I'm covering in this workshop is also referenced in this lesson that you see on the screen, which is on the SCOPES website. So if you want to follow along there as well during this meeting, you can do that, or you can reference it later. But I just want to point it out because it does provide more details on some of the steps that we'll be going through. I'll open it up right here. So here's the lesson on the SCOPES site. So you can see a summary. You can see some of the lesson details, what subject areas it covers, some of the Fab tools that it uses, excuse me, and some of the, you know, the outcomes of the pictures. So while this particular workshop isn't necessarily about making half pipes, which is what I made here, it's about developing the tools that you can, developing the workflows that can generate these kinds of physical models. So again, in the workshop, we're going to cover just the digital aspect, but the lesson goes on further. So here's a kind of a quick overview, essentially, of the workshop. We're going to go through the TinkerCAD model. We're going to go over this, how to use Slicer. Slicer generates cut files. These are the parts of the model. And then in this workshop, or excuse me, I made this lesson originally based on the fact that I didn't have access to a laser cutter for a project. And actually, I developed this at Constructing Modern Knowledge. I want to plug that conference. It was a great conference. I didn't have access to a laser cutter, but I did have access to a projector. So what I ended up doing was projecting the cut files and then traced all the cut files, poster board, cut it out. So in a sense, you can really do this if you have a projector at home. You don't need a laser cutter. You just need patience to be able to cut manually. And I think people do. I did. So maybe there's other people out there who, you know, some of your students who might be motivated to spend the time and precision on finishing, you know, on actually cutting out the model. But so yeah, the lesson takes a kind of a deeper dive into all aspects of that. I do highlight some of the standards, so a lot of math, a lot of projective geometry, for example, that this lesson draws upon. So I do just want to point that out as a resource. But for the remainder of this time, I think we're doing actually quite well on time. I do want to spend time going through the two different pieces of software that we're going to use, and that's TinkerCAD and Fusion Slicer. So let me make sure I'm on track here. Oh yeah, before we get to that, good. I want to call attention to like why this is important to me and why this is, I think, should be important to many people. As like, why should I spend time making these kinds of models? Oh, I do want to say, I do have my half pipe. It has survived use. Here's one little broken piece, but I try to keep these models at hand until my house gets too full of them and I have to start getting rid of them. It's not kind of a painful process. Anyways, this is who I studied with for about 10 years at MIT, Professor Larry Sass. And this is literally what he does all day long. He thinks about shapes, how to deconstruct them, how to fabricate them using new technologies. So here you can see him holding some laser cut models, some 3D printed models. But he has been developing algorithms since the late 90s on how to slice up different types of geometry. And he takes a particular position, you know, a particular angle. His focus is actually in housing. He's an architect by training, but he also uses abstract principles to kind of generate new ideas. So here are some of the more abstract shapes. He leads classes on where you can see really large-scale hands-on projects that you can generate using these kinds of programs. TinkerCAD and Slicer allow you to slice up any scale. So that's what's kind of neat about this Slicer program is you can think of it as like a large-scale 3D printer where you can generate the kind of scaffolding, these parts here that you can see making up a large duck or a mannequin. So he's been doing classes, Larry, Professor Sass has been doing classes like this at MIT for the last 10 years, if not more. And that's where I learned how to do these things. He does a popular class with furniture making and making small scale models that you can then scale up. So again, all the things that we're gonna go over in TinkerCAD and Slicer, you can do this with your students as well, making furniture. This is again a really popular class that every student makes a chair that they have to be able to sit in. Sometimes the chairs do break, but and then lastly, I want to show this example of what I was a part of at the Museum of Modern Art in 2008. We built a full-scale house using Slicer-like technology. So here you can see the scale models that were generated and used to like study different styles, all the different models that we created to represent the different pieces, some 3D printing of New Orleans style shotgun houses. So it's very, I have a very long history with this. So again, I get excited about sharing new technologies that make it a lot easier for many more people to use it. A little background on some of the work that I've done over the years that motivates me, that I think kind of gives, shows how many different people approach this, how it is a really inclusive way of working, of building models together, of using new technology, using digital technology and fabrication technology, how it allows many different people to contribute ideas in a really quick way, in a really creative way of thinking about, you know, all sorts of scales of objects from, you know, handheld toys to large scale, ducks, you know, to mannequins to houses. So it really encompasses a big area of research and potential work for students to get excited about and to like think about, really, you know, put their minds to. So the way that this typically works is what you call a workflow, and that's a workflow is how you go from one software to the next, how you import a type of model and how you export a model into the next. So a lot of people approach digital fabrication and say, I just gotta learn this one software and I'll master it. But in a lot of ways, digital fabrication is about learning how to link different pieces of software together. And so that's what these steps are. The step number one is what we're gonna cover today, is creating a really simple model. Step number two is using a program like Slicer to then cut it up and make it so that you can fabricate it out of flat components. I do want to point out two areas that you typically would use in this process, which is doing an cutting. So here you can see a laser cutter cutting a piece of polished stainless steel. So you can see the reflection of that on the left. And then on the right is a robotic arm that you can imagine beginning to assemble these pieces that we're putting together. Like the same digital information that you can use to send to a laser cutter, in theory, you could use to send to a robot arm to tell it where the mass is and how to pick it and place it. And that's where a lot of my research actually over the last few years, or in the last 5 years, focused on. So if you're interested in seeing more about how to use robots in a creative manufacturing setting, you could, I'll make a plug here for my YouTube page, which is full of videos showing different applications for using the arm, which is what I think kind of is still kind of relevant. Even in COVID-19, we start to think about how we might have social distancing. Using robotic manipulator arms might be a way to rethink how we engage with the built environment like this. So I just want to point that out as a resource if you're interested in checking it out, or even send your students there and kind of give them some inspiration to think about some of the work that's being done that they could possibly go into. All right, so I want to take a little breather and give everyone a chance here to get into TinkerCAD. We're going to start with the TinkerCAD model. So if you have an account, I encourage you now to click to open TinkerCAD. It's just tinkercad.com. And I think what I want to do is I'm going to run through a quick example to kind of demonstrate the workflow between TinkerCAD and Slicer. And then I want to walk Danielle and Katie through, have one of you share your screens. So you'll take the wheel, and I'll describe another kind of operation that you can do in Slicer. So that will be the plan here. So I'm going to go to TinkerCAD and open up my account. So you can see here a screenshot of my account in TinkerCAD. I'm going to, so now you're looking at the website, I assume, yeah. I'm going to sign into my account. It's here. It can be frustrating to have many accounts to sign into. I know that's can be difficult. I think I have actually like 3 different TinkerCAD accounts. It doesn't really matter though. So here's my account. When you open it up, you can see all the different models that you've started to make. And again, I'm kind of basing this assumption on that a lot of you know how to use TinkerCAD. So I'm not going to go into great detail about it. There are some nice online, the fact that it is online makes it easy to do, I think, as a class. You can sign class, you can have students sign up and create accounts, share models. That's a really nice feature to keep in mind, is that even TinkerCAD is like an online community of sorts. Like you can share your models there. You have a profile, like here, I have my profile here. So something like to think about how students might be creating their online presence is through productive means like creating 3D models that other people might download. So I kind of find that fascinating as well, just to point out there. But what I want us to do, first of all, is actually use the gallery. I don't even want us to create, like, to make a new model from scratch. I want to point out some more kind of playful ways that we can do this. So if you click on gallery, here you can see what other people have uploaded to TinkerCAD. And most of these are free and available for you to download to your account and remix them, so to speak. So that's a good starting point, I think, is to not like get bogged down with like, oh, what do I want to make? The point of this workshop is more like, how do you take whatever it is you do want to make, how do you take that through a design process, or through a translation process, excuse me. So what I asked, I'm going to do a search here. What I asked Danielle and Katie to look at, to download, are some simple kind of fun shapes that we can run through Slicer. So I suggested like some animal shapes would be kind of fun. I think I use this one here, but we can do another one. So if I click on this here, a puppy, I can easily click copy and tinker. So I'm going to start with that, copy and tinker. This is going to then generate a new copy of that in my account. So here it's like copy of puppy. And again, TinkerCAD is a 3D modeling program, so you can revolve around, in 3D space. You can add positive shapes. You can add negative shapes. By joining those two, you essentially create, like, you can add and subtract shapes and create, more complex geometry based on those assemblies. And that's how a lot of modeling is still done, is just kind of building it up as you would kind of like with clay, so to speak, subtractive and removing. But again, I don't want to focus too much time on that today. What I'm more interested in is knowing how, making sure everyone knows how to get things out of TinkerCAD. So what I'm going to do is select my dog here, and I'm going to hit the export button in the upper right, and that's going to say, yeah, download and 3D print. But it turns out you can do more than just download or 3D print it. It gives you some options for how you want to download it. So I just leave it at download. I've selected everything, the selected shape, and then I'm going to select STL. That's the most common 3D file, kind of most portable 3D file, allows you to go from many different programs to another. So now in my downloads, I have right over here that file. So it's this file now that we're going to take into Fusion Slicer. So I'm going to move that over there. Open up my Fusion Slicer for Fusion 360. Here is my slicer. So slicer, it just kind of opens up to this blank canvas here. And what I'm going to want to do is import the model. You don't want to open the model. Opening it is like opening a file that's native to Slicer, which we will create. We haven't done that yet. So we want to import a new kind of file type, which is the STL. So here are my downloads. I can see my copy of Puppy. Now, one quick note here. For some reason, if you look at the very bottom here, it has this thing that says change up axis of a mesh. What I want to do is change that to Z. Otherwise, when you import your model, it's going to be like rotated in space in a funny angle. I'm not actually sure why it natively wants to do it in the Y axis, but just so you know, change it to the Z axis. It's going to make it a lot easier for you to manipulate your model. So I'm going to open that, and then here we go. If I zoom in, I can then see Puppy. It's kind of triangulated geometry, and that's fine. So here's my model. Here's here's my design. Some people can spend hours on making a design for something. Sometimes you might just want to start with an immediate idea, and then use the workflow to create a new model, so to speak, create a new idea. But again, the point is just to quickly move between programs and not get too caught up in one for too long. So here I've imported my model. There's a couple of things. On the left-hand side is the main kind of command screen. That's going to, or panel. That's going to be where you change all of your settings, create different kinds of slices through the model. And that's what they call construction technique. So construction technique, they kind of run from simplest to kind of more complicated, where you have stack slices, interlock slices, curve, radial slices, folded panels. I'm going to go through stack slices just to quickly show you the simple one. And then I'll go through, I think I'll start with you, Danielle, since you might have to jet. I'll walk through with you some other examples that we might want to do. So I'm going to do stack slices. And so you can see immediately what this does is what a 3D printer does, which is slice it up horizontally. And here on the right-hand side, you can see all the individual layers of that slicing. So if I go in and manipulate the model in any way, these cut sheets are automatically modified. And essentially that's the magic part of Slicer right there, is a lot of times what makes this kind of work difficult is creating these cut files for laser cutters and nesting all the parts so that they're somewhat organized, and labeling all the parts. So here you can see each part has a number. It tells you what order it goes into. So all that in kind of in a nutshell is what we're doing in this workshop, is generating these cut files, these sheets here. I'm going to go through a couple more steps that I want to just call attention to, and then I'm going to ask Danielle to share her screen with. I think we'll just jump right into your Slicer screen if you're there with your model. But first I want to show a couple things here. One is the assembly steps. This is a neat feature in that what it does is generates an animation that you can control, which tells you the order of all the parts. And this is handy when your models get complex because you're not sure which part goes next, or you have so many parts. This is actually a useful tool. It also communicates, the assembly intention and allows you to test other features of the work. So again, really sophisticated tool immediately. And then the last step that we need to do for any slicer work is to actually get the files, get the plans. That's so on the bottom here, it says get plans. I'm going to click on that button, and here you can see a screen capture of all 4 or 6, excuse me, or no, 8, got some panels covered up here, 8 sheets that this puppy uses. And these sheets, the size of that is determined in the upper left. So this is like a standard printer sheet right here, this 8.5 by 11. So if I wanted to update this and say, hey, I have some bigger cardboard sheets that I can trace this onto, let me make this into a bigger sheets, that's going to let, reduce the number of sheets I need. And actually, I might do a little bit of adjustment here to, not waste this whole sheet over here with these little pieces. I might actually just put those pieces over here manually. So at the very bottom here, you can see the file type. I usually do PDF because that's, again, kind of the most portable document. And then I just hit export to my computer. And I'll say here, cut sheets. Goes to my downloads. And then when I go to my downloads here, here's my PDF of all my cut sheets. And I can use this directly. I could send this to a laser cutter if I had access to one, or like I did with my lesson, I can send it to a projector and I can project this on the wall and trace it out. And what's neat about that is like the scaling minimizes the error. Like the error that your hand will create kind of becomes negligible. And that's, again, how I did this half pipe here was completely just by projecting it to a wall. So you can see it still gets assembled. And that's really the workflow. That's really the bulk of what I wanted to communicate with this workshop, is knowing how to go through those steps and seeing that it's kind of moving quickly. And now that I've gone through it once, I can say, oh, wait a minute, actually I want to make a model that is slightly different or uses this material. I can then go back in and modify those files. But now I want to hand it over to Danielle, put you in the driver's seat here. And I'm going to ask that you do a screen share. I think I can, if I stop and then you do yours, I want to see where your model is.
All right, I'll unmute. And don't worry, Daniel. I've been teaching class at 8:40, but in a distance learning environment, teenagers are not so likely to show up on time at 8:40. There's no bell. All right, so I was gonna try, I started from super scratch. Well, I didn't know how far in the beginning you wanted me to do. Do you guys see my slicer screen now? Yes, okay. So I figured I am actually working on a 3D design unit with my students. I borrowed, this is what my lab looks like. I borrowed a 3D printer from before they evacuated us. And the idea was, I got this from a maker fair, but there's some very simple designs you can do around making spinning tops. So this is a 3D printed, oh, it's hard with the background, but you get the idea. So my idea was to we're actually doing it in SketchUp, but I've had a few kids finish it, but I found one on, I gotta find the STL. Where did I save it? Oh, there it is. I found one on TinkerCAD that someone already did, so it's importing right now. Yeah, so actually I was trying to figure out in TinkerCAD how to tell how big it is, and I think it's pretty huge, this one. So it would never print this large of a tippy top. But yes, this is like the basic design of a tippy top. So do you want me to try to slice it?
Yeah, but what I want to show is another alternative to the stack slices. Kind of one that I like is where it creates kind of a perpendicular slices through it. It might not be the best for this particular shape. It could work. So what I want you to do is go to construction slices or techniques, and then select interlocked slices. So yeah, okay, it's actually, yeah, it is pretty big. So here you can see how it slices through the cube or the sphere at perpendicular angles to each other, and then lays out all the cut sheets. And so, for example, this is where like an assembly order would really be important for you to understand, is like which pieces go first when, because you're kind of creating like a 3D puzzle with this here. And a lot of the art of using this kind of program is, again, knowing which method to match up with the particular shape that you're after. And also manipulating the angles of those intersections. So if you go, I'm going to show one other thing here with you, and then I want to see what Katie was going to slice through. But if you go and click on slice directions in the lower left, slice direction, it's going to, yeah, open up this kind of, these little handles. Try to grab onto any one of those handles, and you'll see you can start, yeah, there you go. You can start to change, yeah, you can change the angles through which it's slicing. And sometimes that will help if like, so you have that long piece, maybe with that long piece, you'd actually want to like rotate all the slices so they're perpendicular to that long piece maybe, for example. But yeah, so you can, if you can have quite a bit, you know, you have many different axes, 3 different axes of rotation that you can rotate your slices through. So again, this is where I would kind of begin to look at the cut sheets on the right-hand side and say the red, you can, if you see the red sheets, that means there's either the piece isn't fitting on the actual cut sheet, or it means there's like a slice that goes all the way through one of the pieces. So it's like a kind of part failure. A lot of times it's kind of a soft warning, so it's not critical. But what I would start to do is manipulate, change the angle and try to minimize the number of red pieces essentially that I have and kind of optimize it for that particular shape. You can also do things like change the scale or change the number of slices. If you go to actually, maybe I can show this with Katie, but I want to just point out that feature of the, actually no, I will do this one with you. If you do the method, if you go slice distribution, go down one and then go by, change the count of the blue arrow, first axis, change that to like 5. So here you can see that when you change and hit enter, yeah, it'll change the number in that direction. So again, it's kind of a combination of like the angle and the number of slices and the scale. So again, if you have like a large material, it might be a different, you'll have a different setup. But that's largely like a lot of the work is kind of going through all those parameters. And often you might have to kind of restart with your file, say, hey, this file isn't working out to begin with. But it's kind of, that's the workflow, is going through it like that. But that's cool. Thank you very much, Danielle, for showing that. Katie, what did you want to slice through?
I have a file of a dog that came off of TinkerCAD. And let's see if I can get this to play nice. So let's share. There's the dog. And are we good? Come on screen. Yes, okay. So here's the copy of the dog that some wonderful person made on TinkerCAD and shared with the world. And
nice. So you said you played around with some of the different features
yes.
in Slicer. Did you find any that you thought would be, like, what did you think would be ideal for this particular shape?
Well, depending on what I wanted to do with it, but the curve. Oh, come on. It just stopped responding.
Sometimes that happens.
Yeah. But I was looking at the curved and seeing how the different layers smoothed out.
Okay. Oh yeah. Nice. Try.
I gotta get that out of the way. And then changing the number of axes and the number of curves, just to see how it would model differently depending on the different shapes. I usually don't think about my objects as curves, so that's why I like thinking about it that way. But in general, as the unplugged, for students to be able to see how the slices would fit together, even if it was doing a 3D print, they could model at home what a 3D printer would be making for them at school if they had access to just a regular printer and it was a small enough design that paper could not be too tedious.
Yeah, not
but
have
there
1,000 layers to it.
what else did you want me to do with this guy?
Yeah, so other one I wanted to show before we move to Q&A is like kind of the more unique one, which is if you go to the menu again there. Sorry, yeah, the construction technique, yeah. And click on folded panels. This one is pretty neat. It's harder to get accurate, but essentially it's like creating an origami kind of skin. It essentially skins the shape, triangulates it, and then gives you the patterns that you would cut and the fold lines, so that you could essentially create like a volumetric figure and like hollowed out. So in theory, like one thing I think is neat about this possibility is you can actually combine techniques where you could laser cut like a structured interlocking structure of this dog on the inside to give it some like massing, and then do this outer technique where you skin it then with another material. And you know, it's based on the same geometry, and it will account for the thickness of the material. So I haven't done this personally myself. I did have, you know, a thought for doing that with the half pipe of kind of creating a skin on that, which was easy enough actually just to do, but I didn't need, I could kind of do that one by hand because it's a rectangle with some, you know, holes through it, if you would. But I think that's a pretty powerful combination of using the tool, kind of thinking of how you can have different pieces together. Again, this one's kind of hard to get to fit. It's not perfect, and sometimes you will run into, I mentioned this earlier with TinkerCAD, and you kind of ran into this, Katie, with like the file was probably pretty big, and maybe caused your computer to crash. Some files can do that, so be careful of like opening like a really big file in Slicer, because it will try, like it'll just keep, you know, doing cycles until it completes it, and sometimes that'll eat up all of your computer's memory in doing that. So just beware, like, you know, some TinkerCAD files are massive and have a lot of detail in it, so just be careful with that. But yeah, oh, there's some nice ones there. There's some, and those I think are even possibly more conducive for doing at home with like, because you could cut those out. If you had a printer, you could cut those out by hand, you know, fairly easily, and then you're just folding paper into a complex shape. But
yeah, there's I was gonna chime in, there's like that whole culture around paper craft, around flattening, you know, 3D models, and then just doing it by hand. And I actually did that as sort of a precursor to teaching 3D design with the younger kids. So this is actually, I like this, it's kind of going backwards again, but definitely thinking about, you know, and it makes it super obvious around the tessellation and the triangles over and over again. So I like that part.
And will it print out, when you print it out, will it print out the fold lines so that a student could follow along and cut and then fold?
Yeah, Katie, why don't you try doing that really quick? And then I think we're just at 11:40 here. I think we're doing pretty good on time. But so if just kind of finish this out here, and then go to like add parts, or where the get plans, sorry, at the very bottom. If you keep scrolling on the panel, yeah, it gets kind of buried sometimes. There you go.
Get plans.
And then,
so there's, there's 4 sheets.
yeah. And then if you go down to the very bottom of the file type, I typically find PDFs a little to the right there. File type, to change that to PDF, it's at EPS, change that to, that's just a different file type that you might want to use. And then you can export to your computer. And I think this will answer your question, Liz, about seeing if the parts, but yeah, that's how I would kind of, go about answering that question, Liz. Like, print it out and get it onto a PDF to see if you can, there you go.
It's not letting me change this one.
Okay, click cancel, we'll try that again.
So, oh, wait a second, let's do it this way. PDF, file type PDF,
Yeah.
export to my computer.
Yeah.
There it is. Great.
And then give it a name, and then you would just have it there as a, and it, you know, paginates it too. So it'll just be, you'll have 4 PDF pages ready to go that you could send, yeah, again, to a regular printer or to a laser cutter if you have access to one. One idea I thought of is, in case, and I don't have a projector at home currently, but you could also put it on a big screen TV. You could like put your cut file on a screen, put paper over that, and then just trace out the paper, and then either like mount paper to cardboard, and then you could slice through that by hand again, and you'd have a very accurate model of a origami puppy here.
You could even do it like on your computer screen, right? Like a scaled down version.
Yes, and I've had my students do that for some of their projects that they would have laser cut. I did a little quick video of how to use your Chromebook screen as a light box. And that was very successful for the elementary kids.
Oh, really? Elementary?
Oh yeah, yep. Something else you could do with these files is if it's in a PDF, if you have somebody has like a Cricut or a Silhouette at home, they could probably also run some of these files through those, and they could be turned into cut files on those types of machines as well.
Oh, like a vinyl cutter. Yeah.
Yeah, yep.
Yeah. Yeah. The cameos or the, yeah. I was gonna say, like, I invested a few years ago in a tiny little projector, and they're like, I was looking up now how much I paid for it, but now, like, yeah, they're a couple $100, but they come in handy for things like this. It's super fun when you're stuck at home. It has to be really dark outside to use it outside, but
True. It's not very, yeah, that's true. The contrast.
yeah.
Dan,
But
if,
for this, yeah.
question. If other people have questions and they want to be on video, do you think it might be like interesting to have everyone like raise their hand who wants to be on video, and then maybe you, since you're host, can let them change them to a panelist so they can answer the questions?
Sure thing. Let's do that.
Okay.
Yeah, I think it's a great time. So yeah, I think that was kind of the bulk of the workshop. We're doing good on time. Liz, looks like Liz is ready to go with the question.
I have a question. Can you imagine how you might be able to use this slicer with like the 3D printing pens? Danielle or Katie, do you have experience using that with students? That might be an interesting combination.
How does the pen?
I can see how it might work. I don't personally have enough 3D printing pen materials to run with students.
Mm-hmm.
But it might help them visualize what their end product would be in a more successful way before they actually print it out.
Thanks.
Anyone? Let's see here. Yep. Poll Kate was saying it's a good idea. Greens. Anyone else want to have any questions? Want to answer questions? Were there anyone? I'll have a question for you, Danielle and Katie. So I asked you two to like do this yesterday. It looks like you did it pretty quickly, and like figured it out. Are there any? Did you encounter any major hurdles or like roadblocks that you could see other people stumbling on and be like, oh, if I only did this, or you know, or I didn't think about that aspect of this kind of workflow. Was there anything that was a red flag for you that other teachers might be aware of?
I've been really thinking about like how to teach kids like sort of understand like that third dimension and like how to navigate the space. So what I liked about it is it kind of shows it 2 different ways. Similarly, because if you go from TinkerCAD to Slicer, it's the same kind of controls. and they're very different in SketchUp, or I'm assuming Autodesk. I haven't used Autodesk in a long time. We're also using Onshape, which is that, you know, trying to navigate just to see things is pretty hard for someone that's like new. So I think this is sort of an interesting way to go at it. But yeah, I think your advice around like go back to like redo or go back to the beginning is a good thing, because this you can like really cycle out into something that's unusable or unprintable, or really doesn't, it's like it's no longer even what it looked like its original shape, which is okay. You can kind of say it's like your Play-Doh, you can squash it into a pancake and make it again. But I think that was good advice.
Dan, somebody has a question, and I think any of the panelists may be able to answer this, but I have a feeling you can. Can you explain how you vary thickness of slots according to the material thickness?
I can answer that. So you change the thickness of the slots by defining the thickness of the paper or the material that you're working in. I'll do a quick screen share to show that. So here I am at my cut sheets. If I go to the material here, you can see there's three dimensions here: the width, height, and then thickness of the material. So if I change this, if I click on this edit, this little pen button here, I can actually make a new material. I think I'm going to add a new material here. I'm going to be in inches just so I can know what it says. I'm going to make this 0.25, so a quarter of an inch, which is like that thick. So it's like it would be cutting out of like a piece of plywood or masonite. So when I use this material, you're going to see how the cut sheets will change. So now I need to go select that material. So keep an eye on the puppy here. It makes it thicker, and then you'll see, I can't see it, but hopefully you can. Let's make a more dramatic difference so we can actually see that there. Sorry, I just shift around here so I can see around. Okay, so I'm gonna go in, edit my material again to this unnamed, and make this twice as thick, half an inch thick, done. And we'll keep seeing if I change this back here. So here you go. You can start to see the thickness change. Oh, sorry, but you wanna see the, I'll change the technique here to interlocking slices. So here, it's a little bit hard to tell because it's kind of so thick. But if we change this back down to like 0.1, done, and then select that. So here you can see the slices, the intersections are automatically defined by that thickness. Good question. Good question.
So another question that is in the chat is, when you get an interlocked form, is there a way to delete one slice or two and have the other forms heal in the appropriate spots to gain strength or stability, or head off the errors where sizes don't quite fit for irregular forms?
Some really good questions here. That's a good one. And I didn't, a few months ago, I didn't know this about Slicer, but yes, you can actually go in and individually manipulate where the slices are. I might need to sit a little closer. One downside of Slicer is it's really small. The fonts are really small, so you have to zoom in. Let's see here. I can, I count custom. If I change the method to custom, I can then go in and I thought, yeah, there it goes. I can go in and move, and you see the cut sheets on the right updating. I can move it wherever I want it to. So that would be like, that would make sense for like this puppy is like, hey, I want to put a leg down there, because he needs to have some structural support. So if, I just want to move my slice to in the right spot there. And then let's look at all of his legs. Actually, they look kind of good. But yeah, I can like grab onto individual pieces. So yeah, it's pretty, you can like set it. That's what I would do, is like set it with the kind of by count or by distance, just to like evenly distribute them as like a baseline, and then change it to custom, and you could really go in and kind of fine tune where each one goes. Any other questions?
Can I ask a question? So slicers, this is a great example. Like I have a bunch of students that are sort of all over the map about what technology they have at home. Like, so Katie, I heard you say that your students have Chromebooks, but my students got offered a Chromebook from school. Some of them have better computers. Some of them, I let them borrow some of the computers from the space even. Shh, don't tell. They'll bring them back. But I wondered if, like, I was really struggling with, even for the kids that are like I've had some requests to have completely offline lessons, like not even on a computer, teaching computer science and digital fabrication. So I wondered in this space if folks had any ideas about how to do some sort of 3D modeling or 3D design like this, where it's not on completely offline, not even using any software.
I have an idea. If you were to send them a file to print and then assemble, or if they were to follow a guide to create their own 3D model based on images that they had to try and figure out how they would turn, well, this is what I have in my hand, and turn this into something that's three-dimensional out of paper, give them that as the challenge, and then you could send them a cut file that they could print out after they've tried it on their own to see how their method is different from the cut files, and then compare and contrast and re-evaluate what they were doing.
I like that.
Yeah, I mean, ooh, I was gonna say what I ended up doing was having them there's a lot of crafts around just making tops around like bottle caps and things around the house. And so like one thing was I had them go build that first and then look at the physics of tops and then say, you know, if you could, and then showed them like that infinite top that like shows up in the movie with, you know, the one that's like, it tells you if reality or not reality.
Inception.
Yes.
Yes.
That one like spins forever. And I said, you know, could you make that out of the bottle caps at your house? No. Okay. That's why you want to start learning, you know, 3D design. So I think we're on the same page, Katie.
So here's our call for the unplugged lessons. Here's where the lesson that I just went over lives in this collection. And we have some description of other, you know, of kind of what we think make good lessons here. But we invite all of you to please contribute a lesson. We're always excited to kind of see new ideas and new kind of interpretations of what it means to be unplugged. I think everyone kind of has their own version that's fascinating and kind of opens up opportunities for creativity, where, you know, you all of a sudden have like a new constraint that you have to deal with, and you can't ignore it, and kind of none of us can. It's kind of strange, but you know, I would encourage you all to take the call for unplugged lessons and use the Scope site to share one. And I just want to thank everyone for their time this morning. I want to thank the panelists, Katy Perry and Danielle Martin. Thanks very much. You guys did a very nice job. Thanks for responding and helping out the community. Please reach out directly to us with any questions or follow-up. Keep an eye out. We're going to be posting the recording of this video on our YouTube channel, so stay tuned for that. And everyone have a good weekend. Thank you again.
Thanks, guys.
Bye-bye.
Thank you.